Hello everyone. In this session, let us talk about the third type of passive electronic component, that is inductor. We have already seen what exactly is a resistor, what is capacitor, different types of resistors and different types of capacitors. In this session, let us see what exactly is an inductor, different types of inductors, on which principle does this inductor work. So this inductor works on the principle called as electromagnetic induction. So what exactly is this electromagnetic induction? Electromagnetic induction is nothing but whenever there is change in the magnetic lines passing through a loop of wire, a voltage is generated in the loop of wire. I mean to say, whenever we are going to take a coil in the sense we are going to take a wire, ಆ ವೈರಿನ ಒಂದಷ್ಟು number of turns we are going to want. After winding or after wounding a number of turns of wire, that wire itself will be called as a loop. So wire ತಗೊಂಡು ಈ ತರ ಸುತ್ತುತ್ತಾ ಹೋದ್ರೆ this thing will be called as a coil. So whenever there is change in the magnetic lines of force in a loop of wire, this itself will be called as a loop of wire, or simply it will be called as a coil. So whenever there is change in the magnetic field, so in this wire there will be a magnetic lines of force. Magnetic lines of force ಅಂತ ಹೇಳಿದ್ರೆ ಈ ತರ coil ಇದೆ, ಈ ತರ loop of wire ಇದೆ. Whenever we are going to connect this to an external source, ಇದಕ್ಕೆ ಒಂದು external source ಗೆ ನಾನು connect ಮಾಡಿದ್ರೆ invisible lines of magnetic field will be generated around this loop of wire. So whenever these magnetic lines of force, which is also called as flux, whenever these magnetic lines of force changes, an EMF or a voltage will be generated in the loop of wire, and this itself will be called as electromagnetic induction. And this inductor works on the principle of this electromagnetic induction. So what exactly is this inductance? Inductance is a property of an element or a circuit which, when carrying a current, is characterized by the formation of electric field and storage of magnetic energy. I mean to say, resistors and capacitors na ನೋಡಿದ್ವಿ. Each material will be having its own property. So inductance ಅಂತ ಹೇಳಿದ್ರೆ will be having a coil, will be having a loop of wire which is having a property which, when carrying a current, is characterized by a formation of magnetic field. ಈ ತರ ಒಂದು coil ಇದೆ. As soon as current starts flowing in the loop, ಈ ತರ ಒಂದು ಕರೆಂಟ್ ಫ್ಲೋ ಆಗಕ್ಕೆ ಶುರು ಆಯಿತು ಅಂತ ಹೇಳಿದ್ರೆ ಅಲ್ಲಿ ಇನ್ವಿಸಿಬಲ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಕ್ರಿಯೇಟ್ ಆಗುತ್ತೆ. Whenever current starts flowing in the circuit, whenever current starts flowing in the loop of wire, then magnetic field will be formed or magnetic field will be generated, and it is also having a capacity to store magnetic energy. This is what is called as inductance. So resistors ಅಂತ ಹೇಳಿದಾಗ it is the property of a conductor to oppose the flow of current ಅಂತ ಹೇಳ್ತೀವಿ. ಅದೇ ತರ inductance is a property of an element or a circuit which, when carrying a current, forms a magnetic field and stores that magnetic energy. So how does that happen ಅನ್ನೋದನ್ನ ನೋಡೋಣ. When a coil, when a current in a coil changes, so I am having a coil like this. So here, as soon as this is connected to an external source ಅಂತ ಹೇಳಿದಾಗ that can either be an AC or a DC, but let me talk about an AC source. Whenever a coil is connected to an AC source, the current starts flowing in the coil. Since I am connecting an AC source, it is continuously alternating in nature. So alternating in nature ಅಂತ ಹೇಳಿದಾಗ the current continuously keeps changing from 0 to maximum, maximum to 0, 0 to again a negative value, negative value in the again 0. It keeps on changing continuously. So whenever the current in the coil changes, magnetic flux link with the coil also changes. We have already seen that whenever the current flows in a coil, the magnetic field is created. So the magnetic field is created because there is flow of current. Since the current flowing in the coil is changing continuously, the magnetic flux linking with the coil will also change. The change in magnetic field will induce an EMF in the coil. An EMF, that is E, will be induced, in the sense will be generated, and the polarity of this induced EMF is such that it opposes the change in current through the coil. This induced EMF will try to oppose the change in the current through the coil, and the magnitude of EMF E will be directly proportional to the rate of change of current. E is directly proportional to rate of change of current ಅಂತ ಹೇಳಿದ್ರೆ di by dt, because I already told you that the alternating current is continuously a changing factor. So the induced EMF whatever is generated, I mean the EMF whatever is generated, that will be directly proportional to the rate of change of current, that will be given by di by dt, and this proportionality constant E, this proportionality constant will be replaced by the letter L. E is equal to L into di by dt. But why this negative symbol is given here? Why this minus symbol is given here? Because it tries to oppose the change in current through the coil. ಹಾಗಾಗಿ ಅದಕ್ಕೆ negative symbol ಇರುತ್ತೆ. So inductance is a property of an element which when carrying a current is characterized by the formation of magnetic field, and that can also store the magnetic energy. Clear? Now let us see what is the unit for inductance. The unit for inductance is Henry, that is denoted by the letter H. If the current changes in an inductor at a rate of 1 ampere per second, inducing an EMF of 1 volt, it is said to be 1 Henry. We have already seen that E is equal to minus L into di by dt. So what will be L now? L is equal to E divided by di by dt. If I am going to neglect the negative symbol, then L will be equal to 1 Henry if the EMF generated is equal to 1 volt, and the current that changes through an inductor, the current changing through an inductor is at a rate of 1 ampere per second. So here the definition tells that if the current changes in an inductor at a rate of 1 ampere per second, inducing an EMF of 1 volt, then it is called as 1 Henry. And as usual, Henry is a large unit, so we are going to use smaller units like millihenry, microhenry, and nanohenry. Milli in the sense 10 to the power of minus 3, micro 10 to the power of minus 6, nano 10 to the power of minus 9. So these are the smaller units what we are going to use in an inductance. So now let us see what is called as self-inductance. I already told you that whenever a coil is connected to an external voltage source, a magnetic field will be created. These dashed lines itself is a magnetic field. So whenever a coil is connected to an external source, magnetic field will be created. So the phenomenon in which EMF is induced in a coil by changing the magnetic flux linking the coil itself is called as a self-inductance, and that is denoted by the letter L. So I am having a single coil which is having a number of turns, and that coil, this is a coil which is having a number of turns, and that is connected to an external voltage source. As soon as the current starts flowing, here the current IL, as soon as the current starts flowing through this coil, magnetic lines of force will be created. Since the source what I am connecting here is an AC source, the current is continuously changing. Since the current is continuously changing, the magnetic lines of force will also be changing. Since these magnetic lines of force, which is also called as magnetic flux, is changing, magnetic flux linking with the coil is changing, and EMF will be induced, and this phenomenon is called as self-inductance, which is denoted by the letter L. So L is equal to minus E di by dt and the head. So the self-inductance of a coil can be expressed as L, which is given by mu naught mu r n square A divided by L, and the unit for self-inductance is Henry, which is also denoted by the letter H. So what exactly is this mu naught mu r n A and L? Factors on which self-inductance of a coil depends. L is equal to mu naught mu r n square A divided by L. I already told you that if I am going to take a wire, this is a length of a wire, and I am going to turn this, I am going to wound this to a number of turns, and now this simple wire, either wire ಏನಿತ್ತು, now this wire will be called as a coil. ಹೌದಾನೆ? ಸೊ ಅದನ್ನ wound ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದಾಗ for support I need something, ಅಂತ ಹೇಳಿದಾಗ here this itself will be called as a core. ಇಲ್ಲಿ diagram ನಲ್ಲಿ ಈ ತರ ಏನಿದೆ, this will be called as a core upon which I am going to wound the wire. Now this will be called as a coil. So factors on which self-inductance of a coil depends ಅಂತ ಹೇಳಿದಾಗ here L is nothing but the length of the coil. ಈ end ಇಂದ ಈ end ತನಕ the length of the wire, the length of the coil is present, and that is denoted by the letter L, small letter L. N, that is the number of turns in the coil. ಎಷ್ಟು ನಂಬರ್ ಆಫ್ ಟರ್ನ್ಸ್ ನಾವು ಸುತ್ತಿರ್ತೀವಿ ಅಷ್ಟು ನಂಬರ್ ಆಫ್ ಟರ್ನ್ಸ್ ಮೇಲೂ ಕೂಡ ನನಗೆ ಇಂಡಕ್ಟೆನ್ಸ್ ವ್ಯಾಲ್ಯೂ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. A is the area of cross section of the coil. Area of cross section of the coil ಅಂತ ಹೇಳಿದ್ರೆ ನಾನು ಕೋರ್ ಏರಿಯಾ ಏನಿರುತ್ತೋ ಅದ್ರ ಮೇಲೆ ನಾನು ವೈರ್ನ ಸುತ್ತೋದ್ರಿಂದ ಆ ಕೋರ್ ಏರಿಯಾ ಏನಿರುತ್ತೋ that itself will be called as cross sectional area of the coil. Mu naught is the permeability of the free space. ಏನು ಪರ್ಮಿಯಬಿಲಿಟಿ ಇರ್ತೋ, ಪರ್ಮಿಯಬಿಲಿಟಿ ಅಂತ ಹೇಳಿದ್ರೆ the capacity of that place, the capacity of that free space to allow the magnetic lines of force to flow, ಅಥವಾ that allow the magnetic flux ಅನ್ನೋದನ್ನ ನಾವು permeability ಅಂತ ಕರಿತೀವಿ. And mu r is the relative permeability of the coil. ಯಾವ ಕಾಯಿಲ್ ಅನ್ನ ತಗೊಂಡಿದೆ, ಯಾವ ಕಾಯಿಲ್ ಮೆಟೀರಿಯಲ್ ನಾನು ತಗೊಂಡಿದ್ದೆ ಅದ್ರ ಮೇಲೆ ಅದರ permeability ಕೂಡ ವೇರಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So on these factors the self inductance of a coil will vary. If I am going to look into this expression, L is directly proportional to N, L is directly proportional to A, and L is inversely proportional to small letter L, and L is directly proportional to mu naught and mu r. So cross sectional area of the coil anta helidaga larger the area of cross section, greater the inductance, because L is directly proportional to A. Number of turns in the coil anta helidaga, since the inductance is directly proportional to N, L is directly proportional to N square ಆಗಿರೋದ್ರಿಂದ the inductance value will also increase. The inductance is directly proportional to the square of the total number of turns. Next, length of the wire, length of the coil. L is inversely proportional to the length of the coil. If the length of the coil is more, the inductance value ಏನಾಗುತ್ತೆ ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. Relative permeability of the core ಅಂತ ಹೇಳಿದಾಗ it is nothing but mu r. Larger the permeability of the core, larger the inductance. Iron core inductor have a higher value of the inductor. Core ಅಂತ ನಾನು ಏನು ಹೇಳಿದೆ, ಆ core material can be different. ಕೆಲವೊಂದ್ಸತಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೆಟೀರಿಯಲ್ ಆಗಿರ್ಬೋದು, ಕೆಲವೊಂದ್ಸತಿ ನಾನ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೆಟೀರಿಯಲ್ ಆಗಿರ್ಬೋದು. ಸೊ ಡಿಪೆಂಡಿಂಗ್ ಅಪಾನ್ ದ್ಯಾಟ್ ಆಲ್ಸೋ ನಾನು ಯಾವ ಕೋರ್ನ ತಗೊಂಡಿದ್ದೇನೆ ಅಕಾರ್ಡಿಂಗ್ ಆಗಿ ಅದರದ್ದು ಪರ್ಮಿಯಬಿಲಿಟಿ ಕೂಡ ವೇರಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So on these factors the self-inductance of a coil will depend. Now let us see what exactly is mutual inductance. Mutual inductance ಅಂತ ಹೇಳಿದ್ರೆ for this we need two separate coils. ಎರಡು separate coils ನ ತಗೊಂಡಿದ್ದೀವಿ which will be wound on two separate cores. And let us tell that the coil 1 is having the number of turns N1 and coil 2 is having number of turns N2. The first coil, let us call it as L1, and the second coil it is called as L2. Now what we are going to do is we are going to connect a external source only to the first coil. L1 ಏನಿದೆ ಆ L1 ಗೆ external source ನ connect ಮಾಡ್ತೀವಿ. ಆದರೆ L2 ಏನಿದೆ we are going to place that L2 very much close to L1. But there is no contact between L1 and L2, but we are just placing L2 very much closer to L1 ashte. So whenever the current starts flowing in the first coil, I have connected an external voltage source to L1. As soon as an external source is connected, the current starts flowing in this first coil. Current flow ಆಗಕ್ಕೆ ಶುರು ಆಯಿತು ಅಂತ ಹೇಳಿದ್ರೆ, since I am connecting an AC source, the magnetic lines of force linking in the first coil that will also keeps on changing continuously. ಏನಕ್ಕೆ ನಾನು AC voltage source ಅನ್ನ ಕನೆಕ್ಟ್ ಮಾಡಿರೋದ್ರಿಂದ. ಈ ಏನು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಕ್ರಿಯೇಟ್ ಆಗಿರುತ್ತೆ that magnetic field will also link with the second coil because the second coil is placed very much close to the first coil. ಹಾಗಾಗಿ ಈ ಫಸ್ಟ್ ಕಾಯಿಲ್ ಇಂದ ಏನು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಲೈನ್ಸ್ ಆಫ್ ಫೋರ್ಸ್ ಅಥವಾ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಕ್ರಿಯೇಟ್ ಆಗುತ್ತೋ ಆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಲೈನ್ಸ್ ಆಫ್ ಫೋರ್ಸ್ ಸೆಕೆಂಡ್ ಕಾಯಿಲ್ ಜೊತೆಗೂ ಲಿಂಕ್ ಆಗಿರುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಫಸ್ಟ್ ಕಾಯಿಲ್ ಅಲ್ಲಿ ನನಗೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಲೈನ್ಸ್ ಆಫ್ ಫೋರ್ಸ್ ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ ಚೇಂಜ್ ಆಗ್ತಾ ಇರೋದ್ರಿಂದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಲೈನ್ಸ್ ಆಫ್ ಫೋರ್ಸ್ ಇಸ್ ಚೇಂಜಿಂಗ್ ಬಿಕಾಸ್ ದ ಕರೆಂಟ್ ಇಸ್ ಚೇಂಜಿಂಗ್. ಕರೆಂಟ್ ಚೇಂಜ್ ಆಗ್ತಾ ಇರೋದ್ರಿಂದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಲೈನ್ಸ್ ಫೋರ್ಸು ಕೂಡ ಚೇಂಜ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಸೊ ಸೆಕೆಂಡ್ ಕಾಯಿಲ್ನಲ್ಲೂ ಕೂಡ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಲೈನ್ಸ್ ಆಫ್ ಫೋರ್ಸ್ ವಿಲ್ ಕೀಪ್ಸ್ ಆನ್ ಚೇಂಜಿಂಗ್ ಕಂಟಿನ್ಯೂಸ್ಲಿ ಆ್ಯಂಡ್ ವಿ ಹ್ಯಾವ್ ಸೀನ್ ದಟ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಇಂಡಕ್ಷನ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಲೈನ್ಸ್ ಆಫ್ ಫೋರ್ಸ್ ಚೇಂಜ್ ಆಯಿತು ಅಂತಂದರೆ an EMF E will be generated. Since magnetic lines of force is continuously changing in L2 and EMF will also be induced in the secondary coil or in the second coil L2. That is what is given here, and that phenomenon or that induction of an EMF in the second coil because of the change in the current, because of the change in the current or EMF in the first coil, this phenomenon is called as mutual inductance. When a current flows through a primary coil, L1 will be called as a primary coil, L2 will be called as a secondary coil. When a current changes, when a current flows through a primary coil, it produces a magnetic field. Some of the magnetic field flux gets linked with the secondary coil. Obviously, any change in the magnetic flux or current in the first coil will cause a change in the magnetic flux linked with the second coil. This will produce an induced EMF in the second coil. This phenomenon of inducing an EMF in one coil by changing the current or EMF in the other coil is called as mutual induction. And the expression is given by M is equal to minus E divided by di by dt, where M is called as mutual inductance. L self inductance ಅಂತ ಹೇಳಿದ್ರೆ ಬರೀ ಒಂದೇ ಕಾಯಿಲ್ ಇಟ್ಕೊಂಡು ಒಂದು ಕಾಯಿಲ್ಗೆ ಎ ಸಿ ಸೋರ್ಸ್ನ ಕನೆಕ್ಟ್ ಮಾಡಿದಾಗ ಅಲ್ಲಿ ಒಂದು ಇ ಎಮ್ ಎಫ್ ಜನರೇಟ್ ಆಗ್ತದೆ and that will be called as self inductance, which will be denoted by the letter L. But here ಒಂದು ಕಾಯಿಲ್ ಅಲ್ಲಿ ಕರೆಂಟ್ ಚೇಂಜ್ ಆಯಿತು ಅಂತಂದರೆ ಇನ್ನೊಂದು ಕಾಯಿಲ್ ನಲ್ಲಿ ನನಗೆ ಇ ಎಮ್ ಎಫ್ ಇಂಡ್ಯೂಸ್ ಆಗ್ತದೆ ಅಥವಾ ಇ ಎಮ್ ಎಫ್ ಜನರೇಟ್ ಆಗ್ತದೆ ಇನ್ ವಿಚ್ L2 or the secondary coil is placed very much closer to the first coil, and that phenomena is called as mutual inductance, which will be denoted by the capital letter M. And that mutual inductance of a coil can be expressed as M is equal to mu naught into mu r n1 into a divided by L, where n1 is number of turns in the primary coil, n2 is number of turns in the secondary coil, a is nothing but the area of cross section, and A is area of cross section of the core. ಯಾವ ಕೋರ್ ತಗೊಂಡು ಆ ಕೋರ್ ಮೇಲೆ ನಾನು ವೈರ್ನ ಸುತ್ತಿರ್ತೀನೋ ಆ ಕೋರ್ದು ಏರಿಯಾ ಆಫ್ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ and L is nothing but the length of the coil. So these are the factors on which the mutual inductance will depend. So let me conclude this session at this point. In my next session, I'll be dealing with the different types of inductors and how the inductors can be connected. I mean to say how the effective value of inductance will be varied when they are connected in series and connected in parallel. Thank you.